Welcome to Algebra 1, Unit 7, Lesson 5 Practice Problems. We have one vocabulary term to review, and that is the zero product property. Remember that if we are multiplying things together and getting 0 as the answer, one of those things that is being multiplied together must be 0. So the first practice problem says rewrite each equation so that the expression on one side could be graphed and the x-intercepts of the graph would show the solutions to the equation. What they mean by this is that the first step we always take needs to be to make the equation equal 0. Because if it equals 0, then we could graph it and the x-intercepts would be the values of x from solving the equation. So in number 1, we have 3x squared equals 81. To move positive 81 to the left, the opposite of positive 81 is negative 81. So we're going to subtract 81 from both sides, and this is going to become 3x squared minus 81 equals 0. Now you would be able to find the solutions, and the solutions would be the x-intercepts. Number 2, we have 5x on the right, and we need to move that to the left side so that it equals 0. So the opposite of positive 5x is negative 5x. So this is going to become x minus 1 times x plus 1 minus 9 minus 5x. Number 3. Here we have a positive 32 on the right. So what we're going to want to do is subtract 32 from both sides. So this would become x squared minus 9x plus 10 minus 32. And finally, number 4, we have a positive 29 on the right side. The opposite of positive 29 is minus 29. So this would become 6x times x minus 8 minus 29. And on all of these, I should have written equals 0. Because as long as it equals 0, now when you find the solutions, those solutions will be the x-intercepts. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Here are equations that define quadratic functions f, g, and h. Sketch a graph by hand or using technology that represents each equation. So in function f, we know two things. First, a is positive, so this is going to be a parabola that opens up. And c is positive 4. So this is going to have a vertex at y equals 4, and it's going to open up. Function g. We have a factored form here, So we're going to have x equals 0, which puts an intercept at the origin. And we know that x plus 3 equals 0, which means x equals negative 3. So we're going to have a second x-intercept at negative 3. If we were to multiply this out, we would have x squared plus 3x. We can see that the x squared term is positive, so we're going to have a parabola that opens upward. So our vertex is somewhere right in between. It's going to go down, come back up, and we have our parabola. And then for function h, we've got the standard form x minus 1 squared, which we could think of as being x minus 1 times x minus 1. Here, if x minus 1 equals 0, then x equals 1. So this is going to be a parabola that only has one x-intercept at 1, 0. And because this is positive, x times x is x squared, it is going to open upwards from there. Number 2, determine how many solutions each f of x equals 0, g of x equals 0, and h of x equals 0 has, and explain how you know. So first, we're looking at f of x. So f of x equals 0. We can see that this parabola never crosses the x-axis, so it has no solutions. Next, we have g of x equals 0. We can see that it crosses the x-axis at negative 3 and the origin. So g of x equals 0 has 2 solutions. And finally, h of x equals 0. We can see that the vertex just touches the x-axis. This means h of x equals 0 has 1 solution. When we refer to solutions of quadratic functions, we are talking about the x-intercepts. So if you are looking at a graph, then your solutions are where that graph touches the x-axis. And there are only these 3 possibilities. No solutions, because it never touches the x-axis. 2 solutions, because it touches the x-axis twice. Or 1 solution, because the vertex is the only point touching the x-axis. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Mai is solving the equation x minus 5 squared equals 0. She writes that the solutions are x equals 5 and x equals negative 5. Han looks at her work and disagrees. He says that only x equals 5 is a solution. Who do you agree with? Explain your reasoning. So, we're multiplying two things together and we're getting 0 as an answer. What we're really doing, since we're squaring x minus 5, that is x minus 5 times x minus 5. This is the same factor done twice. So we only have one possibility here, and that is that x minus 5 equals 0. So what we would do is add 5 to both sides, and we would find our answer that x equals 5. This means that Han is correct. If you have any questions about how I solved this problem, please use class time to ask for further clarification. This brings us to our last practice problem for Lesson 5. Decide if each equation has 0, 1, or 2 solutions, and explain how you know. So on number 1, we have x squared minus 144 equals 0. So if you think about this logically, by adding 144 to each side, we would have x squared equals 144. By taking the square root of both sides, we would find out that x equals positive 12 or x equals negative 12. So this has two solutions. For number 2, we would actually be doing the opposite. We would need to subtract 144 from each side. So we would have x squared equals negative 144. In this class, we will not cover complex or imaginary numbers. So right now, there are no real numbers that you can take the square root of or square and get a negative number. So this would have 0 real solutions. Number 3, we have a factored form x times x minus 5 equals 0. In this case, x could equal 0 or x minus 5 could equal 0, which means x would equal 5. So that is 2 real solutions. Number 4. Here we have x minus 8 squared equals 0. This is just x minus 8 times x minus 8 equals 0, which means we only have one factor. We just have that one factor twice. So x minus 8 would need to be 0. And if we add 8 to both sides, we find out x equals 8, and we have one real solution. And finally, number 5, here we have x plus 3 times x plus 7 equals 0. So either x plus 3 equals 0, we subtract 3 from both sides and find out that x equals negative 3, or we say that x plus 7 equals 0, we subtract 7 from both sides and we find out that x equals negative 7, so there are 2 real solutions. If you have any questions about how to find the number of solutions that a quadratic equation has, Please use class time to ask for further clarification before we move on to Lesson 6.